Good afternoon, everybody. My name is Chris Harris. I work for Tengen out of the London office, part of the field engineering team. So today I'm going to talk to you really about the sort of things you should consider when running MongoDB in production. Clearly I'm going to do this in English, so excuse I don't speak French. If you do have any questions, though, just please shout out or put your hands up and we'll take them as I go. So let's imagine that I've got a MongoDB project. Some development team has just given me this new project and they're telling me that it runs MongoDB. How do I kind of deal with this, and what sort of things should I kind of consider in terms of high availability? So obviously we could start at the very beginning, right? I know, let's have a single node of MongoDB. Kind of one way of going. Now obviously if you have a single node, the things that could potentially go wrong here is that node could fail. So that's going to die. Well, you've got no replication, you've got no backup, you've just got human intervention now of basically bringing the server back online. So can we do anything different? We've heard people talk today about having replication and how does replication work. So let's actually look at replication, right? Let's imagine I've got multiple nodes, right? So I want high availability. I want data replication to occur. So let's say I've got 1, 2, and 3 nodes. It's nice. So the way that MongoDB works is, what happens is when you have multiple nodes in a replica set, there's an election process called. So one of them will be nominated as the primary node. The primary node is the node that basically will accept writes for you, because we want the ability to have consistency and transactions support when we write documents, so we can have the ability that we know from a consistent perspective what the state of any document is at any given time. So what happens is an election is called, one of them is nominated as being the primary node, and then the other two are secondary nodes, which basically are just replications of the data. So the data goes into the primary and then replicated to 1 and 3 in this use case. Well, things can go bad, right? My little primary down here could kind of get into trouble and get shut down. So there's this automatic election process that occurs. They negotiate to each other. And they say, right, he's dead, right? He's gone away. So they basically call this election and negotiate who can be the next primary. So what happens is, based upon who's got the most up-to-date data and how many other nodes that you can see, because you have to have a majority in order to become a primary, the new primary is elected. So your system will automatically continue to accept writes now because you've got a new primary. The drivers in MongoDB all have replica set support, so that they know this election process can occur, and they know that a new primary could suddenly be elected. So now you've got a new primary, writes are going to go this way and again replicated to node 1. That's kind of nice, but what happens then, hopefully I can fix this machine and it can bring it back online. So I bring it back online. He's obviously out of date at this point. How do I recover him? So when he comes back online, what will happen is that he'll go into a status called recovery, or recovering. And what's happening here is, when he's in this state, he's talking to the primary and trying to get up to date. So he's trying to get the most up-to-date data coming back down to himself. So once he's then got all the latest data, he then is changed to a state of back to a secondary, and the system is back to as it was originally. This guy is now the primary. You've got 2 secondaries. There is support for you to actually control, in terms of priority, who is the primary at any given time. I'm not going to go into that today. That's another topic. But that's at a high level how replica sets work. So now I'm going to do something really crazy. I'm going to attempt to create from scratch a replica set and show you what I've just shown you. Now, I wouldn't attempt to do this on a normal database, but I'm going to attempt to do it with MongoDB. So, you didn't want slides, so here we go. So I've got 3 nodes here. Well, actually, they're not started. There's no data. There's no nothing. Right? They don't even know anything about each other. The only shortcut that I'm going to do is the fact that I'm running him on my little local box here. Normally, you'd have multiple servers, but I haven't got that. So I'm going to have a node here that's going to run on port 27019, and I've got one up here on 27018, and one here on 27020. This is just going to be my working prompt. MongoDB has a shell in which I can interact with it. So at the moment, all I've got nothing pre-installed. I've just basically unzipped MongoDB. So let's start them up. Okay, so they're all started up. They're basically started up in replica set mode, and they don't know anything about each other, right? So they're just saying, well, I don't know what to do. Please initiate the configuration. They'll say, I've literally done nothing. So I better configure it. That's maybe a little complicated. So here's my configuration. Can you see that? Oh, I can make it a bit bigger. Come on. Okay, I'll just change the font size then. That's a little big now. Let's go. That'll probably do. So, as everything else in MongoDB, it's a simple JSON document. So all I'm going to say is my configuration is not my configuration. Oh, it's further down. I got one down here. Oh, I was about to break my own demo. That would have been pretty bad. So 24. So my configuration has got a name called demo, and I've got 3 members. So here I've got a host, here's my IP address, and here's my port numbers, and that's it. Right? That's not, people can understand what that means. So I've got members, an array of members, IDs, and host names. Simple, right? Okay. Let's copy that. Let's go connect to one of the MongoDBs. There we go. So I've connected to 2718 and paste my config into here. There it is. Right. So I'm cheated, no cheating going on here, right? I just pasted it in there. Paste that in there. Okay, so now I just do rs.initiate config. And the nodes will start to communicate to each other. So take a couple of seconds. So these are now getting their configuration. Here they go. So one of them in a second is going to be elected as the primary. You'll see basically they're negotiating with each other who's going to become the primary node. State is set up. So I can actually ask it what is the current state. So I can do rs.status. And here we go. Still recovering. So we have a primary node being elected here. So what's the name here? 2718 has been elected as the primary, and the others are now syncing off themselves to basically then become the secondary. You can see here, this one is now in state of secondary. This one is also now in state of secondary. So if I re-ask it what the status is, you can see secondary, secondary, and a primary, right? And I now have a replica set up. So let's insert some data. Make it very simple. Let's do.
It kind of looks like all 3 are pretending to be secondary.
Nope. You can see I'm connected here to a primary.
This one.
Yeah, this one's a primary. Because the shell is actually a little bit clever. It knows I connected to a primary, so it's changed its prompt to you are on a primary. It's kind of nice for me to know that I'm actually on a primary. So I can do db. I've got no data, right? So let's create a database. Let's create a collection and everything on the fly. So db dot, let's call it demo dot save comma name. I'll give it a name. This is my document I'm going to create. So let's say Chris. This is my document that I'm going to create, right? That looks okay to me. Save. There we go. So I just save the document. I can obviously find my document. db.demo.find. And in theory, that should come back. There we go. So here's my little document, Chris, that I've just saved. It's been given an ID. It's in the database. Okay? Easy. Now, which one was the primary? I believe it was... which one? 18. Well, the question is, which one's 18? I tell you what, let's just be crazy and kill that one. So you can see now an election, if I connect to 18, you say, I can't connect because he's dead. Right, I killed him. He is now dead. He has elected himself as being the primary. He is now still the secondary. He didn't change state. So if I now connect to 19, I'm now on the primary. And in theory, if I do db dot, what was it, demo.find, I should have my document, right? Which I do. Great. So the system does work, and I can obviously re-elect him back in here. They all realize that he's now come back online, and I can do rs.status. And you can now see I still got a secondary, but this one in the middle is now the primary, and this one is the secondary. And if I did, for some reason, want to connect to 18 now, 18, you can see that I'm connected on the secondary, right? So that's basically creating a replica set in probably less than 5 minutes. So, okay, it's fairly easy to configure. How should I really set it up? Let's play this. Let's go back to some slides. So, if we now have this concept of primaries and secondaries and replica sets, what should I do in production? Well, people normally start off like this, is that they have 2 nodes and something called an arbiter. The idea of an arbiter is the fact of I don't want to have 3 machines. Basically, I need 3 nodes to have a majority, because if I have 2 nodes, and one fails, then I haven't got a majority of node, because one is not a majority, so I can't become a primary. So the idea is, I need at least 3 nodes, but I can use one as an arbiter. And an arbiter is simply in the system as a voting node. So he's a small little lightweight process I can put anywhere I want, doesn't really matter where I put him. And if, for some reason, a server fails, an election is called, and basically the arbiter has a vote. He says, I can't be the primary, obviously, because I can't hold data, but at least I'm here and you can see me. Therefore, there's 2 nodes in the system, and you can become the primary. Sure, that works. The disadvantage of this approach, if you basically have that running on a single data center, you want to be aware of the fact of what happens if life gets really bad. I have power supply goes out on that particular set of servers. The network, the data center, 2 nodes fail, right? Bad things can happen. It doesn't really protect you against that. It does give you the idea that I have replication. So if one node does fail, my system will obviously automatically go to a primary like I showed, but it doesn't protect you against power failure or network failure. Okay, let's fix this a little bit. So what we could do is have them on different power supplies. Different networking. People call this, or at least if you looked at AWS, which a lot of our customers are on, you could have them on multiple availability zones. That's a good idea. That kind of works. That does protect us against power outages. Doesn't protect us if the data center fails, but at least we can protect against network failure. there is something in MongoDB when you write. Now you can say, I want to write with what's known as W2. W is to say, I want my application to, instead of just firing a write request saying, please write, and then come back to me when it's just fire and forget, you can say W2, whereby you could say, I want my application to wait until both of the servers have acknowledged they've received the request. That kind of sounds like a good thing to do, right? So I'm going to write. These two are going to wait for, they acknowledge that they received it, then I carry on in my app. And I simply say, save with W equals 2. The disadvantage of this is, if you lose a node now, and you have W equals 2, with no timeout, what's going to happen to your application is that it's going to basically block forever, because, well, until this node comes back, right? Because it couldn't replicate to two nodes because one of them is dead. And you can't replicate to an arbiter because, well, you can't contain any data, right? So you can't really use W2 unless you have a timeout, so be aware of that. I was talking to somebody in the break who was experiencing that problem. So you could fix that. And you could say, well, instead of using an arbiter, what I'll do is I'll have a data node. Well, that kind of works too, right? So now, if it does fail, and I'm using W equals 2, at least I have two nodes that can still receive that request. This doesn't protect us, obviously, against data loss, or data center loss. We can have two nodes that fail. So how can we address the data center problem, right? Because bad things can happen, right? Somebody could drive a truck straight into our data center. That's not good. So, what about this? Let's put one of the nodes in the other data center. That could work. Right now, I'm replicating across multiple data centers. Let's imagine this is my primary data center. So I could, there's nothing wrong with saying these have higher priority. So if a failure occurs, then the primary should really be coming to this data center. You could even make this a hidden node so that it can never become the primary and not available to your app. Think of it more of a backup node. This kind of works. There are disadvantages of this approach, right? So there's advantage of the fact of now I can cope with the fact that, yes, I have I have the data in the data center, but if this data center fails, this guy over here can't become the primary because he can't see a majority, right? He is 1. These two fail, the data center blew up. This guy is on his own, can't become a majority. He's got the data, but he can't become live. Okay, let's go even further. Some of our customers actually do this. So the nice thing on MongoDB is that you can start small and go quite complicated. So what happens if I want a hot data center, right? Well, why not do this? You could have 2 nodes in this data center and 2 nodes in this data center. You could have different priorities if you wanted to do that, or you can tag them to say, I want to ensure that my write reaches both data centers if you wanted to do that. And then you have this little guy up here. I don't know, he could live in another data center. He could be on, these could be your 2 local data centers, and i.e. in your, private data centers, one in London, one in France, I don't know, wherever they are. And this could be on the cloud somewhere. It could be Amazon EC2, it could be anything, right? I don't really care. But basically you have 3 data centers now. So if this fails, well, he can now have a majority, right? Because he can see 1, 2, 3, so he could become a primary, and then basically your system can still work. So you can have then a hot standby across data centers. This could be primary, this could be live, normal production, high priority, and then you could have a secondary hot standby one with lower priority. Okay, so that's kind of replication is what I wanted to show you. The next thing to think about is, well, I've got these machines. How big a machine should I have, right? What should I think about? What should I not really care about? So the way that MongoDB works is obviously you have collections. So documents live in collections. and you have indexes. So as with what you've been used to in your normal kind of original kind of database world, you have indexes to do queries, makes it efficient. Kind of we still obviously have indexes in order to you to do efficient querying. So the way that it works is MongoDB is all memory mapped. So the collections and indexes are mapped to memory map in virtual memory space. So MongoDB basically has all its files, it tries to map them straight into virtual memory. And then it basically flushes to disk as it goes on. So everything is mapped in memory because it's extremely fast performance. So you have virtual memory, you have mapped memory, and then obviously you have behind there the physical memory, right? That's in your MongoDB. So when MongoDB is asking for, let's say, when I did demo get Chris, his document, it asked his virtual memory space, and I wasn't in the load, so it probably got it out of physical memory and it came back to me, right? So that's how it works. Now, this makes MongoDB extremely efficient in terms of how it can receive data and how it writes data. Now, obviously, there is only a certain amount of memory you actually physically have in your box. So when MongoDB tries to get something out of the physical memory and then it page faults, it has to basically go to disk, right? So if it's not in physical memory, the way that operating systems work, it's not here, not in virtual memory, can't find it in physical memory, I page fault and I go to disk, right? And then I return the data. Now clearly, right, everybody knows this, getting data out of memory is a lot faster than trying to get data out of disk, right? So what you want to be able to do is keep what we refer to as the working set, right? The data I'm currently working on, let's say I'm using your website, it's using MongoDB underneath, and I have multiple requests that I'm coming in. Let's say I'm placing an order, or I'm trying to get a product information, or whatever I'm doing on your website. Now, I'm likely to be making multiple requests to MongoDB. It could be get product, could be update my order, could be multiple things in which I'm doing in my session. So what I want to try to do is to keep my working set in memory as much as I can. So think about working sets. Think about your document sizes that you're going to have. So are they going to be large documents? A document can't be bigger than 16 megabytes in size. So that actually is a fair amount of data in a single document, if you wanted to get to that size. But that's basically the size of a document. So how many documents am I going to have? What are the size of the documents? Do I need to query this information quite regularly? Or is it more once I've created this, whatever I'm creating, let's say I'm reading off a log, right? I'll read this data off a log. Maybe I'm just archiving the data, so I'll just stuff it and just archive it. I don't need to read it. So that would basically depend on how much working memory I've got and what type of operations I'm doing in my use case. So if I go, I'm going to do it here first of all. So in the shell, there are a bunch of operations that you can do to help you understand, what are the sizes of the documents that you're running, and what the size of the indexes. So a simple way, there's quite a lot of them, but just to give you a quick overview, you can do basically ask the collection. I had test. This is a collection here, and you can say stats, and that will give you information about what's going on. So it will tell you what's the size of the data in my current collection, what's the average size of my documents. So that's kind of useful because I'm trying to work out, what's the size of my working set, how much memory do I need. So if I therefore know what the average size of my document is, I can then calculate, right, I might be doing a read and a write and a read and a write, and the average size is therefore this, and I'm doing these many operations. I need X amount of working memory. I can basically, how much of this is actually stored on the disk, the size of my indexes, right? What you want to at least make sure of is that your indexes are in memory, because clearly, if you're going to start querying, and the efficiency you're going to get is by using an index. You want to be able to navigate that B-tree index tree graph as quickly as possible, so keep them in memory. So this basically then tells you the size of the indexes you currently have. It's kind of useful as a guidance when you're doing your first load of load testing. Please don't do what some people do and just say, well, what I'll do is I'll use my laptop, just as I've just done just now, and insert like 5 or 500 records into my MongoDB and then say that's enough load testing, let's throw it into production. Do some load testing, understand what your data is, understand basically what size of indexes do I have, because it's very different running a system on your laptop to running it in production. It's fairly obvious, but not everybody does it. So let's think about disks. Yeah.
Can I come back on
Sure,
the index,
you can.
please? What you said is that the index should be completely in RAM, in memory. That is not common in a relational database. So it's a
Right.
different
It's
mindset.
a different model, yeah. So the different thing to think about in MongoDB is MongoDB doesn't really use CPU power at all. It's just because it's got no kind of relational calculus to have to calculate, because it's got no joins and complex transactions that it needs to maintain. So CPU power is not really something we care about. It's much more about, if we've got rid of all that, we can do a lot more. But doing a lot more means that basically the things that we actually care about is the amount we can store in memory and the speed of my disks.
So I have to think about having all my index in RAM. And if I have something like a catalog of a website,
Yep.
should everything be in RAM too?
Go for it.
It really comes down to what your application needs. So simplistically, you could say all my index needs to be in RAM. But realistically, for your application to work well, you need enough of the index and enough of the data for those use cases to work well. So imagine you've got a website. What's the first thing that somebody might need to do? They might need to log on. So you could probably make a fair assumption that that person's identity is not in memory. So that first access, they would have to page into memory. Now, as your login procedure works, you may update the time they last logged on or the IP address they last logged on from, and you'd want to update that data, that document. Now, your working set should mean that that document, after you've read it in and you do the update, stays in memory. And the piece of the index that references that document stays in memory as well for the length of that use case. So that's what we talk about for your working set. It should be the data and the indexes you need to remain in memory for those typical use cases to execute without needing to page data in again from disk.
So you mean my user profile with the login and the password on should it completely be in memory? Because if I have 15 million users, they don't all connect every day to my website, right. So it will be a huge cost in memory for me.
It's simply the parts of that data you need. So let's say you've got 15 million users. Let's say you have 500,000 log on each day, and as they are logged on, they stay logged on for 30 minutes. So you might want to size your system so you can store 500,000 profiles in memory.
Okay.
To keep that in memory.
And the index with all usernames associated with it, should it be completely in memory?
Again, it can be just part of the B tree. But the interesting thing it comes down to, as Chris was saying, the pattern of usage.
Okay.
So if you think about user profiles, it's random. Random people can log on today. So that means you've got random access to that whole B tree. So the likelihood is you've got a large part of that B tree in memory. Now you can imagine a different type of access. Let's say you were storing Apache logs, and Apache logs have the date on them. And let's say you were just looking at the Apache logs for the last 10 minutes or the last day, you can imagine on the index you've just got that right segment of the B tree. All the rest of the B tree is still on disk. So again, it comes to understanding your use cases and patterns of index to get an optimal sizing.
Okay. And what is a typical RAM that you advise on production?
More.
More? Okay.
So if you're going to choose between getting a 2-core and a 4-core and an 8-core machine, we would say buy less cores and use that money to buy more memory.
And today SSD drive is quite famous. There is a hype on it. Is it because so we have RAM, SSD, and the classical old-fashioned disk?
Yes.
So would you advise more RAM, or would you say a bit less RAM and more SSD, or what is a cursor?
That's a great question. So SSD gives...
maybe it's...
That's fine, you carry.
Sorry, I should have...
So SSD is great. It gives very good random performance these days. But you are still doing an I/O from the system perspective. So the cost of accessing an SSD is not the same as accessing RAM. But SSD is still much faster than accessing a regular SAS or SATA drive. But SSDs are expensive. If you've got a small enough data set that fits on SSDs and you can afford them, we would say use them. But if you've got a very large data set, it may be cost prohibitive to put it on SSD. And then you can mix SSDs and a regular SATA disks. So for example, you could put the journal files on SSD and the regular data files on SATA drives.
Okay, thank you.
That's okay.
Does somebody have a question related
Question?
to this? No?
No?
Thanks.
We'll carry on. I was going to talk about disks. Yeah, you could have single disks. You basically, if you've got a single disk, basically you're going to have the speed of the single disk, so it could be 200 seeks. We care about the speed of the disks, as Alvin was talking about. So you could basically have multiple disks and have RAID 0, but you're not going to get really performance out of the disks. So our recommendation is to go RAID 10. You can basically then have striping and mirroring and then increase the amount of speed that you're getting out of your disks. We've talked about SSD, so I'm not really going to go there again. Use them if you've got them. But they're expensive.
On RAID, because usually on database, they tell us that you don't need the same RAID for journal logs and for data.
Right.
Is it the same idea for Mongo?
Right, you can separate out the journal log, as Alvin was mentioning. So you could basically, if you wanted to have high-performance journaling, you could basically say, I want the journals to go onto the SSDs and then my data files to go onto my normal drives if you wanted to do that. So you can basically...
Because RAID 10 is consuming much more than...
Sure. So you can basically target which, whether or not it's going to be the journal or the where you want to place certain files.
Yeah, the other thing to consider is how much do I love my data?
Right.
Okay. With a single disk, you could argue you don't love your data very much because that disk breaks and the disk will break, very regularly, and that means you've lost all that data. The great thing with a replica set is you've already made multiple copies of that. But if you love your data more, you'll ensure that you'll have multiple drives there so you can survive the failure of any single disk and still have this data available. Obviously, replica sets provide both a data protection and high availability, but if you lose that node because of some hardware failure, a disk fails or a CPU fails, then it means that you're running in a degraded mode. If you had a set of 3 and you take one node out, you've only got 2/3 of the resources available. So you kind of want to size your environment to protect for those events that you care about. If you think you've got very unreliable disks, for example, you're using a hosting provider like, say, Amazon, and you're using EBS drives, they have a very different performance characteristic than a physical drive on your chassis. And so you'd probably want to have more drives if you're using a cloud solution. You can probably get away with less drives if you're using physical dedicated
But on
hardware.
EBS, do I know if I'm using Red 0 or Red 10 with Amazon?
On Amazon EC2, basically, think of a single EBS drive as looking like this. And then what you can do is you can take multiple EBS drives and then put them into a RAID 10 configuration.
Okay. Okay, thank you.
All right. Yeah.
If you run Mongo with Amazon EC2, do you
Yep.
get what?
Oh, sorry.
If you run Mongo with Amazon EC2, what kind of variation in performance and reliability can you actually count on if you're going that route?
So we have a lot of successful customers who are using Amazon EC2. What we suggest to everybody who's running on EC2 is that you do load and performance testing for your application on EC2. EC2 performance, there is very few SLAs that Amazon guarantees. The performance will vary over time. And so what we have typically see, if I...
Yeah, go for it.
Where's that picture?
There you
Here we
go.
go. What we typically see on Amazon EC2, if these are 6 EBS drives, they are giving you different latency and different throughput over time. And so you may find on a Sunday afternoon, one of your drives is suddenly going from giving you a 40 millisecond response time to a 600 millisecond. Okay? Now, if that was your only drive, then you would have a performance problem of throughput for that entire file system. And so this is the advantage of putting in RAID 10. So if one drive is misbehaving in terms of performance, what will happen in RAID 10 is if you're trying to read from that, the first disk that responds will give that read request. So it will help if you, for reads if a drive is misbehaving. Unfortunately for writes, if you're writing to this group and one disk is going more slowly, you have to wait for the acknowledgement of both drives before you can actually acknowledge the write for it all. And so, again, this is where replica sets can help you. Let's say your primary is having a particular set of problems with its EBS drives. What you can do is you can force the primary to step down, and one of the other members of the set can take over, which isn't having EBS drive issues. And then you can do some background maintenance of swapping out the drive or rebuilding the RAID group, etc. So again, the replica sets give you some flexibility for the operational side of maintenance and keeping your cluster up and running and healthy.
Any other questions on that? No? Okay. All right. So that was really a section on kind of what do you think about in terms of how to set up your disks, how to look in terms of the amount of memory that I should be using for my MongoDB. Now, when I'm in production, one of the things clearly I want to think about is how do I monitor this? How do I actually understand what's going on at any given amount of time? And also the fact of, I get into the situation where something is going terribly wrong, right? So somebody says, my production is failing, please help me. And you say, right, let's have a look of exactly what you're seeing in terms of disk access, how many locks are you having, is anything queuing up, how is MongoDB behaving? You can get a snapshot of what's happening right now, but you also obviously want to see, is this a problem that's built up over time because you haven't got enough machines, or is it something because you haven't got enough replica sets, or you need to go to sharding? Basically, understanding what's happening in your environment is critical to maintain production. So, MongoDB comes with a set of tools to help you do this. So, the first thing to get your head around is something called Mongo Stats, which I can actually show you here. So I've got, for all my little demo, still my 3 nodes running. Let's move to my primary. Here. Yeah, here's my primary node. Let's bring up Mongo stats and bend down a little bit so you can see. I'll actually do it here. Let's create another tab. I don't know, call it page, just make it different color so you can see it. Pardon? Yeah, up here. And this one up here. Can we all see that? Okay. So let's do Mongo stats. Mongo stats to port. It'd be a good idea if I actually told it where it was running. Port 2708 19. There we go. Actually, what I'll do, so that you can actually see it properly, I'll stretch it across. Is that quite enough? Give me a little bit more. Pars keeps coming online. What's you supposed to do with that? So here, it's not quite enough. Let me see if I can reduce the text slightly. There we go. So, can you see that? So basically what Mongo stats is telling me is how many inserts, how many queries, what operations am I currently running on my system. It's also telling me how much memory is mapped, how much virtual memory space I'm actually using. It's telling me how many locks is MongoDB actually currently having to do in order to do its read and write locks. The things to watch out for is, index misses. Is anything queuing up? Because I've got lots of locking going on. So are other users, other connections queuing because it can't do its operations? So then I got classic things like network in, network out on the current time, right? So you can see that popping along. Let's throw some data in. So let's actually, the script supports Mongo JavaScript. So here's a little bit of a dirty script that I just wrote. All it's going to do, you can just increase the text so you can see it. So all I'm going to do is a little for loop that basically insert, going to loop 10,000 times, and loop for each iteration. What I'm going to say is insert quiz, essay, and exam. For each time, calculate a random score and insert this record into MongoDB, right? So I'm going to end up here with about 30,000 records being inserted into MongoDB, right? So you simply copy this, some bit of JavaScript, and I'm going to paste it in here. So in theory, what we should see once I've pasted this in, paste in here, as I hit return, there we go. It's a little fast. You can see 3,000 records in, 17,000 records went in. You could see that there was a small amount of locks, read and write locks happened. I have a machine, basically nothing queued up, and it was processed 30,000 records pretty quickly. So if I actually look in here, just to prove they are actually in here, db.scores. What was it? Find. Just do find. I think it was find. .count. Right. There we go. So here are all my records, 30,000 of them. And if I really wanted to show you them, I could do this. Find, and obviously they're all in there. So you can see all my documents. Okay, so let's actually take it a little bit further. So anybody who did miss it, then we could actually insert even more documents. So let's just, where did that bit of code go? Oh, I cut it out. That was never good. There you go. Let's go crazy. Bam. Paste. You have to remember, whilst I'm doing this, there's obviously replication happening from my previous demo, right? So it's still replicating around. So there we go. There you go. And you can see that I'm doing a large number of inserts where I insert something like 3 million records into my MongoDB. So you can see here the number of inserts, commands that are happening, and you can see my lock count going up because it's having to get a write lock, write my data because I'm doing an insert. And then you can see basically the network traffic. So Mongo Stats is a very useful tool if you basically just want to quickly look on a command line what your MongoDB environment is doing. You can connect to a Mongo S if you wanted to do that and basically see what the entire shard is doing. I'm not going to cover sharding today, but it's a useful tool. Another tool in which you can use is we have MMS. So MMS is basically a hosted monitoring platform that we run. All you have to do is install an agent. So you create a little account that basically has your email address in and very simple information about who you are. Then you go to the site and you download an agent. You install the agent on your platform. The agent already has configuration information about your account information, who you were. So it's a custom agent for you when you register. You start the agent up. You either point it to a Mongo S and it finds the entire cluster for you, or you basically looks in terms of what's running on its current environment and discovers you've got a replica set. And then it's a hosted platform, so it's then going to basically report up into the cloud on mms.tengen.com under your account what's happening to your MongoDB. So you can see in this example here that I've got primary, 2 secondaries, I've got a standalone server. This isn't my machine, this is just a demo lab. So you're not going to have the data I just inserted. So you can get the same information here. So if I look into this given node, the speed of the internet, here we go. You can see that I get very similar information that I was getting from Mongo Stats. So I can see things like, let's just make this a little bigger. So I'm just going to increase the size of that graph. So I basically can see the operations. So if I just hover over something, I can see here the amount of queries. This is currently under 66.8. But the nice thing about MMS is that clearly from this graph it's giving me historical data. So I can basically then realize that, is it the fact that this server failed because, I don't know, you were having disk use problems, or you were having, you don't have enough memory, or you're getting a lot of lock sort of things queuing up. I can see, is this a gradual problem that you started off with a few things queued up and now you've got everything queued up because you didn't do anything 3 days ago or whatever it was. So you can look obviously into the host statistics. Say very similar to what you're getting out of Mongo Stats, but I can also drill in if I wanted to, and if I've set it up to do this. This is an opt-in feature that I can look at the hardware that it's running on, so what is the speed of my disks, and what the I/O I'm getting through. I can look at the database itself, so things have multiple databases. There's no data in this one, but how many collections have I got, what's the average document size, so very similar to when I did collection.stats to show me the current size of my document. Maybe my documents are increasing in terms of their size because, I don't know, I've got arrays that keep growing for some crazy reason. Yes?
How is this meant to be used? How is this meant to be used? As an investigative tool or as an alerting tool?
To be honest, it has some alerts. Right now they're fairly basic in terms of it basically tells you if a host is down or the agent is down. That's as far as alerting currently goes. We know that's something that needs to be built out a bit more.
Right now it's more an investigative tool.
It's more of an investigative tool, right? Okay. Something that you know. Where I use it personally is because it's a hosted platform. I can, let's say that there's a support request I'm helping somebody on and they happen to be using MMS, then I can basically go to their account in MMS and I can look at their servers and say, well, I don't know, you currently have this many servers and they're performing like this and you've suddenly seen a peak of traffic. Did you have a marketing event because crazy marketing people went out and started a campaign and and didn't tell you about it. My marketing pass is looking at me. Or is the fact that one of your servers is down and you're redirecting all the traffic to one of your nodes, right? So you basically, that's what we use it for. What I also find useful, from my perspective, is because it's heart beating, because it's coming back and telling me the state of the pings of the servers, so it's also giving me configuration information of how you set it up. So I can quite easily scroll down here. I scroll down here and say somebody reported to me and said, my driver keeps telling me I am out of connections. And that's kind of maybe something somebody would tell me. So I can scroll down here. So I can see, well, you've currently got 18 available connections, but you've currently got 7 open, right? So if a guy suddenly then went on this machine and tried to open 50, it's not going to work, right? So that gives me an indication of how the server is performing. You can, this is not set up on this server, but you can set up profiling. Very much. Okay. You can set up profiling. So I'll actually do it here. So what you can do, thank you, Dr. Sarah. So what you can do is you can do db.set profile level. So the profile level of MongoDB basically says 0 means, I'm not going to log anything in my profile collection about what's happening in your MongoDB. So the default is don't do any profiling, right? Option 1, if I say profile level 1, what this means is track slow operations. So in MongoDB, we consider by default slow I'll raise that slightly so you can see it. The default behavior, it's going to mask, so you see that? The default behavior is we consider anything that's taking longer than 100 milliseconds to be a slow operation, which is, for some databases, actually pretty fast.
Yeah, so think of this as the equivalent of the MySQL slow query log.
Right.
You can actually start setting this up to start trapping all of those long-running or slow-running queries or operations.
So typically, if someone says to me, my customer is complaining that he's always getting a slow page or something is not responding in time, what you can do is you can turn profiling on dynamically, and that would basically then record slow queries, and then you can start investigating. And that may be because you're missing an index. It's quite a common reason why you want to do that. So what I can then do, if I wanted to, so I got profiling level on. Did I turn that on? Yes, I did. The default behavior is that it will basically track anything that's a slow query and put it into a collection of slow queries, like everything else. It's a collection. If you set it up correctly and you actually opted in to MMS profiling support, then that slow query profile log can be published up onto MMS. So then it allows you to have a central point of seeing what's actually happening. We deliberately have set it in so that's an opt-in feature, because obviously that's going to release query information out, which could, for some people, be sensitive. So you have to opt into MMS profiling support. So if I've got a slow query here, let's try to make something go quite slow. So I've got, how many records did I have in my database? Scores, I think my database was called. Find. Oh, let's do find.
On this opt-in,
Yeah.
I think it's
Sure.
on this opt-in feature. I imagine you can set it up so that internally you can use it as much as you want. And the day you need Mongo 10-gen support, you can just turn it on and then turn it off once you've got the support.
You've got it, yes. So the idea is I can still use profiling locally, just as I'm about to do here, and it's not going to talk to MMS. And then I basically have to turn on in MMS and click the button and say, right, please release my profile log, and it will do that for you. Yeah.
How much bandwidth can we expect to require if we use MMS? How much data?
It's basically what it's doing is it's releasing statistics every minute based upon what you're doing. So it's basically just as Mongo Stats was doing in terms of the statistics it's releasing. So what's the amount of bandwidth out of that?
Yeah, I mean, if you just pull up the screen of the ping stats.
Yeah.
Essentially what's being posted every minute, as Chris was saying.
This one?
Yep. Is this JSON document. Okay. So the size of this JSON document is going to vary depending on the number of replica sets you've got, how many shards you've got. But essentially it's just this one document that's getting posted. It's this one document that's getting posted every minute. Okay. So you can have a quick look at the size of that. I would say it's kind of a K or so. That's being pushed.
HTTP?
It's being pushed over HTTPS up to our service.
And I will have a question on MMS. In the room, who can publish data from production server to an external company like this? Who can open firewalls? Yeah, it's okay? Yeah. Because if we see bunks, do we still have bunkers now? Yeah, can you open firewalls like this? Okay, telcos? Yeah, telcos, maybe you can.
Yeah, so it's a great question. At the moment, this is a hosted service. Obviously, what we're doing is developing and making sure the measurements and the key performance indicators are the correct things for operating a MongoDB cluster. So we've based this on our experience. We're working with our customers and the community to refine this and make this better. There is a goal for, in terms of enterprise support, there are companies like banks, for example, who will want to host this on site. And that's potential for an enterprise feature which would be part of a subscription build. There's no commitment to making that available in the next days or weeks, but that is on the roadmap.
Okay, thank you.
Is there a plan to integrate the Mongo Stat feature like right into the database? Like it would be really nice if I could just flip a switch and have that right into a CAP collection.
See, I'm not aware.
So, I mean, in effect, this is what MMS is doing. It's not only taking the Mongo Stat information, it's taking some other system statistics and writing that to an external system. It would be easy enough to do to essentially do something quite similar yourself. It's not built into the product right now.
Right. Because there are other plugins out there as well, like some people use an Nagios plugin and other stuff out there if they want to monitor MongoDB. There's lots of other ways of getting hold of the same statistical information. Yeah. Like another one.
Yes, back on the replica set demo.
Yes.
On the client side, how does the connection pool behaves when a primary node goes down?
So what happens is the drivers are aware, because we have drivers for basically almost all languages these days. So they're aware of a replica set and the fact that the primary can change. So what you do is you connect your driver, first of all, for your first connection to a node inside the replica set. That's then told what members there are. If that primary fails and we're in an election process, then...
Which could take
some time, right? Which could take a few seconds for it to wait. Then your application at this point can't take a write. But you might be that write on that particular shard. So if you've got multiple shards, so let's say you've sharded your environment, and you've got another shard that's basically you're targeting. For some reason, you're inserting data. You could potentially write to another shard.
And just to add to what Chris was saying, in terms of the connection pool, what happens to avoid kind of pending data or pending writes on connections, what happens at the point where we detect the primary has gone, then the connection pool drops all connections and then re-establishes all connections, so you don't have any stale data or stale connections. Right. So what you'll see from an application point of view is you may execute a write, and then you may get an error thrown on that write, or you may get an exception, a socket timeout, for example. And then from your code perspective, you can decide what you need to do. You could do a retry. It may be a case of you have to throw it back to the user to say, please try again later, or some other behavior. But you get that trapped in your code, and then you can decide what is the appropriate thing to do.
Yeah. No.
In the situation that you showed where you had 2 data centers and 2 nodes in each, replicating to the secondary data center, 2 secondaries, is that being written from the master twice, or will one of the secondaries in the secondary data center pass it on?
So right now, what happens is there's a log inside the primary called the op log, which is a capped collection, basically has all the operations that the primary is on. So the nodes are all connected to that and are reading the primary's op log. Now, if you're in a recovery state, for example, one of the nodes in one of the data centers has failed, and then you brought him back online and he's trying to recover. During the recovery process, he will recover off his nearest peer. But once he's secondary, he then replicates off the primary.
Yeah, there is. Oh, I should get in the middle. There is a ticket which you can go vote on. If you don't have an account on jira.mongodb.org, go create one. It's free, and you can upvote. There's a ticket to do chaining of replica sets. Yeah. So if you care about that, please go upvote it.
We just break for Q&A.
Back on the monitoring subject, is there any plugin or daemon to input Mongo stat data into, let's say, Graphite or other monitoring systems?
So yeah, I mean, there's a bunch of plugins. If you go to the monitoring page on the wiki, it lists all the current ones, but there are plugins for Zabbix, Cacti, Munin, Nagios. It's easy enough to go build your own as well. As part of this subscription build for MongoDB, there's also SNMP support. So if you're using HP's OpenView or some other kind of enterprisey type product that uses SNMP, that is an option as well.
Shall we talk about backups, because we have 15 more minutes?
I wasn't even in my deck, but yeah, okay.
But, we just have 15
We have 15 more minutes. Basically, I was going to summarize at this point anyway. So just to really quickly summarize where we are. Don't really use a single node inside your production environment, because basically that gives you no data protection, right? And no high availability, because obviously if a single node fails. If you are going to do it, please use journaling. It's on by default in the latest version of MongoDB. So definitely use it for a single node environment. If you are 2 nodes, the difficulty with 2 nodes is, yes, you get data protection, i.e. the data is replicated to another node. However, you don't get high availability, because if one of the nodes fails, that single node can't become a majority, so he has to go into secondary format. So to remember that the way in which it works is, if for some reason you can't discover a majority because more than half the data center is broken, then what will happen is the nodes will go into secondary mode, and then the only thing you can do is read off secondaries at that point. So two nodes don't give you high availability. You can do 3 nodes, as I've talked about. The minimum you can get away with on a 3-node is 2 data nodes and an arbiter. That's typically how people do start. That does obviously give you data protection and 1 node failure. It's quite common for people to then say, well, tell you what, if 3 is good, I'll just do 4, right? 4 is better than 3, surely. Actually, no, because yes, it still gives you data protection, but if I got, let's imagine I've got 2 nodes on this side and 2 nodes on this side, then what's going to happen if I have 2 nodes fail? I can't get a majority because I'm still on 2, right? 2 is not a majority of 4, so it actually still only gives you 1 node failure, not 2 node failure. So basically, go from 3 to 5, right? Skip that out, and then you can now see a pattern of odds and evens in terms of how you would set that up. So to summarize in terms of where we are, to kind of close it off, would be the default behavior for MongoDB in a replica set is the primary is always consistent, right? So when you do a read and a write, the default behavior is actually to read and write off the primary. You can opt in either in your driver and say that I want to opt in for the entire database to accept reads off the secondary, or you can actually control it at a more fine-grained level and say for this collection, or actually even for this operation. So there might just be a single call whereby I'm willing to read off a secondary. A secondary is eventually consistent, and that's because the replication is happening and you're tempted to do a read, right? So the primary is replicating to the secondary. If you do a read, that write may not have got there yet, so you might get the old version, but it will eventually get there, so it's eventually consistent. I talked about and even showed you the fact that if a primary fails, it can automatically fail over, and you can bring it back with recovery. Understand your use case, right? Understand how your application works, right? What are the patterns? Am I doing archive data and I'm not doing much reading and writing? Am I doing it because I'm doing a website with users that basically I'm controlling the fact that I want to read a product or hold this basket with order information in? So understand your working set and clearly monitor what's going on. That's basically what I had in terms of content. So I was going to open it up for the last 10 minutes on Q&A.
Do you want to talk a little bit about backup?
So they really want to talk about backup, don't they? So you can back up MongoDB. There's a number of different tools. Let me quickly show you then. There we go. Let's quit this. So let me just do ls here. Sure. There are multiple tools. Actually, thank you. I'll use this.
We'll move more.
Oh, okay. So the simplest way, okay, the really, really basic way of doing a backup, I wouldn't recommend that you do it like this, but you could, in theory, you could basically shut the node down and copy the files, right? It's got data files, right? So you could copy files, right? Now, the nice thing about the files is that they are, and the reason I brought that up was more to the fact of you can take a group of data files and move them somewhere else. So let's, for the sake of the discussion, say that you have a large set of data, you've got terabytes of data, and you want to move it somewhere, then you could just copy the files and move into another server, right? And a server would start. The other tools which you can use is that you can use, 2, not 3, I can't count these days. You can use Mongo, dump, or Mongo export. So Mongo dump basically works very much like SQL dump in the fact of MySQL, where you can dump the database. Now, you can actually say Mongo dump and then give it the database that you want to basically dump, because you might have multiple databases inside your MongoD. The thing in which Mongo dump is going to do is that it is basically going to give you the full BSON definition, right? So it's going to give you your indexes and your data in BSON format. You can use Mongo export to say that you wanted to target certain records. So you might say that I want to have, I don't know, say I've got multiple customers in my database for some reason, and I basically only want to export certain records for customer A. So you could give Mongo export a query and a collection and a database to execute on, and it will return back JSON for you. So that's a nice way of getting hold of a large amount of records. That is the tools in which you can start thinking of using. The way in which you could actually then think about it in a replica set. Let's imagine I have a primary, I have a secondary. Let's have another secondary over here. Now these are going to replicate to each other, yeah? So these are basically, the data is going to come in and it's going to replicate to the primary. Now they're going to have the same data. So you could use Mongo dump, right? Well, I could use Mongo dump on the primary, and that probably is going to basically, affect my production environment. Probably not the best idea in the world, but I technically could. Or what I could actually do here is I could actually set up in the replica set, just as in my configuration I had before, is I could set up this node to be a hidden node. So you can just give it hidden. And that would mean that it's not available to the application. So the application can't see it, it can't read off it, it can't never become the primary. So it has a copy of the data. So now I can do Mongo dump on this one, right, without affecting production. That's kind of.
Would you do that temporarily? Was it like, are you just going to set it as a hidden node from the starting point when you define your?
Well, typically people do.
Yeah. Okay.
Because that's their backup strategy, is that they'd have, this could either be in a different data center,
okay,
or it could be just a node in a different rack or somewhere else.
Right.
So
Okay.
typically you've dedicated a machine to do that. So then you've got this hidden node. Now, what about if this happens? Let's say that I've got, let's say I'm a bit crazy, right? And I've gone onto my machine, to my shell, and I made a mistake, and I've said, drop database. Oops. I know we've all done this, right? So we drop the database. This is straight replication across them all. So it's going to drop the database here, replicate my command here, and drop the database, and oops, dropped it on my backup as well. So you can, if you want, have slave delay here. And just put n, let's say 5,000, i.e. it could be 5,000. Basically, I want this node to be delayed in terms of replication. So he's always going to be 5 minutes behind, or X amount of period behind. So then if I am a bit fat fingery and I press drop table, it's going to go here and here. At least I have some time to recover, because he's not going to get that command for X period of time, right? So he's going to get 5 minutes behind, or an hour behind, or whatever it is. So this then becomes your backup node. It's not available, you do Mongo dump and you pull that out. Yeah.
A question for you guys. Is anybody using kind of LVM snapshots or snapshots from a storage array or EBS snapshots at all? No? Nobody? So how are you backing up your existing databases? Mongo dump? And if you're running Postgres or MySQL, how are you guys backing that up?
They don't.
Export, okay. So the great thing with this strategy is, obviously you can use the replicas for high availability and data protection, but you can also use these replicas for a secondary use. Obviously, one of those could be backup. You can take this node out of the replica set in order to actually run a backup from it, without affecting the kind of production usage on the primary. equally, you could use one of these secondaries to go feed a solar index or feed another application or feed a data warehouse for your BI analysts. And so now you've made multiple copies of the data, you can put those multiple copies of data to work, not just for your regular application, but for all other usages of that data as well within your enterprise.
In the case you were describing and you use your fat fingers, how would you stop the replication? Let's say you drop the primary and the first secondary. How do you stop the replication going to the hidden node?
Well, he's only...
Yeah, you have 5 minutes. You just realize you've been an ass and you drop the database. What do you do to save the day?
Well, 5 minutes is usually not long enough. Because if you've just done the drop collection, you've probably gone, oh, that's fine. You go, oh, panic. And that panic cycle is usually about 5 minutes in my guesstimate. So you kind of make this, probably 30 minutes, 60 minutes, whatever you think is reasonable. And it gives you that amount of time to break that replication. And then, essentially what you do is you take down this node and then you bring it out without the replica set.
Yeah. Okay. Thank you.
And this is actually, a faster way than trying to recover from a tape backup or even a snapshot, because you don't actually have to move the data around. You can actually take this down, bring it up as part of a new replica set, then add these guys back into it, and these will automatically resync from this data from an hour ago.
I have a short question on this. How much RAM? Because you say if you love your data, you buy Red 10, and you buy a lot of RAM and so on. So these boxes are quite expensive, even if they are cheap boxes, but they are expensive in this kingdom. What kind of hardware should I buy for this? Same RAM, or can I go just with disk?
Great question. So the typical recommendation is buy identical hardware for all of these nodes. And the simple reason for that is the primary will change over time. Now, if you have different hardware, then the primary is going to give you a different response time. It's going to have different throughput. But also from an operations management perspective, it gets kind of confusing if you do have different hardware with different topologies, different number of disks, because you've got to keep that mental map in your mind as you're doing this. So to make life simpler for yourself, make all these machines the same specification. That means they're going to give you equal throughput, equal response time as you fail over through the system.
But you can if you wanted to. Well, if for some reason, you're buying new hardware, you're rolling out new hardware, you can set priorities here. So you could actually say, this is a faster box to this one, therefore this has higher priority. So if it all is alive, this one is the master or the primary.
What's the status of an hidden node in replica sets? It discounts in the majority for the election process?
So the question is, how does the hidden node get used? So there is a command that's executed by the drivers called isMaster. And isMaster will report all the members of the set that are not hidden. Okay, so this is why this hidden node will, as far as the driver is concerned, not be there. Now, obviously it is a member of the set, it gets to vote.
Right, so you wouldn't have an arbiter sitting here. Well, I think that's where he's going. Yeah.
So just to continue on this coexistence of different hardware, if the backup node, I guess you would want more disk and less power, then it's possible to do that.
Yeah,
right?
absolutely. So if you were going to have this as a dedicated member just for backups, yes, you could buy, instead of expensive SAS disks, you could buy really cheap SATA disks and have a much lower CPU. Clearly, you'd want to keep it hidden. You'd want to set its priority to 0 so that it would never come over and be the primary. And so the key thing is when you have a failover occur, you'll typically want the failover to occur between similar spec machines. If you are deliberately having a machine which has got a different use and you never expect it to become a primary, sure, you can get a different hardware spec.
Okay, and if you have a large number of coexisting machines, which means that inevitably at some point you will have sort of different hardwares just because of evolution. Then is there approach to set the priority so that you only have the new machines that become masters when it's their turn? Or
yeah, so the priority can be set between 0 and 100. 0 being it's never a primary.
It's actually a floating point. You can get really,
yeah.
You've got loads of options.
So, you know, let's say your first set of machines are priority 10. If you get a new spec of hardware which has got faster disks or more memory or more CPU, you would simply add those into the replica set. They would sync themselves and become up to date, and then you can set them as a higher priority. And what happens in a failover is we'll always elect the machine with the highest priority and the most up-to-date data. So if you have higher priority nodes, it will automatically try and select those.
That's also the fact of if you've got a higher priority node that failed, and then you bring him back online and recover him, he will actually, once he's back and fully recovered into secondary mode, another election is called, and he is then re-elected back as primary.
Exactly. So if this was priority 10 and these are 2 priority 5s, and you take this machine down for maintenance, what will happen is obviously, let's assuming this is not hidden, one of these guys will be selected. At the point this machine comes back and gets put back into the set, because it's now higher priority, the first thing that will happen is they'll go into recovery mode in order to get up to date. And when it's fully recovered, then an election gets called again, and it's now the highest priority, so this will fall back to being the primary again. So if there's reasons in your application because of the way you're laying out machines across racks or data centers, you can force certain types of behavior with the priorities as well.
I see that you first have to set up your configuration of nodes to set your replica set. But can you at any point add new machines and new instances to one replica set without having to restart everything from scratch?
So the idea of a replica set is that you can add in a member dynamically. So you could add in a data member, or you could add in an arbiter, or you can remove an arbiter or remove a member. You can also, I haven't spoken about it today, but one next strategy on scaling would be to think about sharding. So think of a shard as being basically multiple replica sets that are connected together. You can actually make a replica set a shard and then dynamically add in more shards without taking the system down. And one of the tactics that people do for things like rolling an upgrade would be the fact of I could actually upgrade this to, let's say that I've got, let's say this is Mongo 1.8.6. Right, make a number up. This is my Mongo version, and I want to roll up. I want to put in Mongo 2.2.0.2. Then what I can do is, people think, well, what I want to do is I want to create a new member. Well, actually, what you can do is say, well, let's upgrade this to 2.0.2. He then, because you can have multiple versions running side by side, you then basically step him down, and then he upgrade. This becomes the primary. Then you upgrade him as 2.0.2. So the idea of MongoDB is that we should be doing rolling upgrades, adding servers, adding shards, without taking your system down.
Yeah, so Chris has given you a great example of another use of a replica set, which is you can do maintenance. It could be Mongo versions, you could be upgrading the OS, you could be adding more memory, but you can do this as a rolling outage, which means from your operational point of view, instead of doing this at 3 o'clock in the morning, you could actually do it during daylight hours, because your application can remain running because you've got these additional members. And so the operations people tend to kind of really like this because they don't have to schedule maintenance at 11, 12 o'clock at night. They can actually do some of this during the daylight hours, as long as your set has enough capacity to deal with the fact that you're running in a diminished mode at this point. I think we're out of time, right?
Out of time. Yeah, we are here for the rest of the day, so if you have got any questions, just find
Okay, thank you. So now we have a talk with Dwight, and we have to keep the schedule because there is a Mongo user group at 7 p.m. at La Cantine, and it's very short. So thank you for understanding.
Thank you.